जज को एक और कॉल कर रहा हूँ, ओके? देख लो वो मीट में।
मेरे को ये बताओ स्ट्रीमिंग लिंक कहाँ से आता है? गाइस 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 स्ट्रीमिंग लिंक कहाँ से आता है?
नहीं भेजा अभी तक। अरे लीवी ने
हाँ,
भेजा, उसको पूछो।
लिंक कहाँ से आता है? ये ऊपर का ही लिंक भेजूंगा, बट आई डोंट थिंक सो ये भेजना
ऊपर
है।
का? हाँ, ऊपर का ही।
अरे हाँ, शेयर का एक ऑप्शन है, रुक जाओ, मेरे को मिल गया। सेंडिंग व्हाट्सएप पे डाल रहा हूँ, तुम लोग सब जगह डाल दो, बिकॉज मैं डिस्कॉर्ड भी खोल नहीं सकता, ठीक है?
हाँ हाँ।
डाल दिया मैंने, चेक इट।
अरे सुन, तेरा डिस्कॉर्ड एको हो रहा है उधर।
मेरा डिस्कॉर्ड एको हो रहा है लाइव स्ट्रीम पे? हेलो?
यस।
ओके ओके।
ये अनाउंसमेंट में डाल दे।
Requesting before we start, requesting all judges to turn on their cameras and if possible everyone present over here. Thank you. Welcome to Rookie's Hackathon for this year, that is 2022. And we'd like to thank you for coming. And as we start this judging session, I would once again remind everyone, those who are present here, to turn on their cameras. Let us begin.
Calorie tracking, recipes, diet plans, water tracking,
So, our judges for today are Akib Ahmed, Anish John, Devesh, Rajat Dyaks, and Smith Shah. Mr. Akib Ahmed, having completed his BTech from Vishwadaya Technological Institute, Akib sir has vast technical knowledge and work experience. Mr. Akib Ahmed has completed his master's from University of Arizona and he is currently working as ML engineer with Tiger Analytics. Apart from this, he has also trained and mentored over 7,000 students from all over India, from various universities and from abroad as well. And not just students, he also has trained a number of employees from various NMCs. His technical knowledge includes Python, SparkSML, Terraform, Kubernetes, etc. Mr. Akib Ahmed also has certifications in various languages. We welcome you to our hackathon, Mr. Akib Ahmed.
Thank you so much.
Our second judge for today is Mr. Anish John. Mr. Anish John has completed his bachelor's degree in computer science engineering from Father Conceição Rodrigues College of Engineering, Bandra in 2019. He has also received a postgraduate diploma from IIT Bangalore in machine learning and AI and is currently pursuing his master's degree in machine learning and AI from Liverpool John Moores University, UK. Professionally, he has 2 years of experience in software engineering and a year of experience in data science. He currently works at GEP as a data scientist. Traditional ML, image processing, text processing are his areas of forte. Anisha, we welcome you to our hackathon.
Thank you so much.
Our third judge for today is Devesh Rajadiaks. Mr. Devesh Rajadiaks has completed his BTech from VJTI. His current fields of work include AI and healthcare technologies, and with 24 years of work experience, he is currently the founder and CEO of Cree Labs Private Limited, a startup working on artificial intelligence. Due to his extensive research in AI, an AI platform called Creescope is built that can convert dark data to structured data. Mr. Devesh Rajadiaks is also the founder of the Society Artificial Intelligence Mumbai, AIM, which aims to bring together people interested in the AI domain in Mumbai. He has been a knee student of science and tries to be a science communicator. Mr. Devesh Rajadiaks also has spoken on many forums and in panels discussion about artificial intelligence. He has also written many articles on AI. He is also a writer of Science magazine, Yours Sincerely. Yours Sciencely. Devesh sir, we welcome you to our hackathon.
Thank you.
And last,
Spandan, we have a next judge here, I guess. Yes.
I just saw that. Last, Smith Shah. Mr. Smith Shah is a strong engineering professional with a Bachelor of Technology, BTech, focused in computer science from SVKM's NIMS. Smith is a certified data scientist with a demonstrated history of working in the information technology and services industry. He is a skilled in data science, machine learning, deep learning, and computer vision. Having worked in multiple companies and having a vast work experience, he is currently working as onboarding trainer in data science at Deloitte. Smith, sir, we welcome you to our hackathon.
Yes, thanks. Thank you.
At this time, we will proceed and start with our judging rounds. I would now be calling the first team in the meet.
Also, judges, I guess you'll have received the form link to fill in the marks. Is it accessible to all?
No. How am I supposed to receive it?
I'll put it in the chat box here.
Okay.
So in that drop down, just select the team name. We'll be mentioning it, and the below is the rubrics in which you have to evaluate the team. Below, we have even given a place for mentioning your remarks. So do mention the same. And if any doubts, do let us know.
Team Runtime Terror, are all your members in?
Yes, all the
Yes.
members can.
Okay. May I request all of you to switch on your cameras?
Yes.
Yeah. Thank you so much. So the first team today for the judging round is Team Runtime Terror. You may proceed with your presentation.
Yes.
Guys, you all will have 10 minutes for your presentation and 5 minutes would be the Q&A. So do manage your
Okay.
time accordingly.
Yes.
All the best.
Hello, guys. Hello, everyone here and all the judges. We are Runtime Terror, URH1. We are presenting the team today by Aiden Samuel, that is me, and Chris Coraya, that is my
That's me.
another team member. This presentation covers in short the key points of our entire ML model, and it will give you a gist of what we have done.
Yeah, so EDA being explanatory data analysis. Through the analysis, we learned that the capture and transfer are only two types to have shown signs of fraud occurrence. And there's an error shown in balances after every transaction, but no column exists with the errors displayed. Thus, we created error in transaction column. Then fraud transactions have shown error close to zero. Thus, one of the parameters that help us identify the fraud. And data cleaning, the target variable for the data set is selected as is fraud and not is flagged fraud. As is flagged fraud does not contain enough data significant to fraud. Data cleaning process includes the converting of categorical variables and transfers them into numeric form. This step emphasized on how important data cleaning after EDA impacts a data set and how we can build even better models with better results.
Yeah. So the modeling process, the first model that we had selected was XGB Boost. But as we learned through the process of evaluating that model, the precision and recall score of that model were too high. The model was being overfitted. Thus, what we did is, instead of using XG Boost, we switched to logistic regression. In logistic regression with the raw data, we were getting an F1 score of 42%, which wasn't enough for our model prediction. Thus, we used the same logistic regression model with undersampling. We reduced the data set to a total of 16,000 values with a perfect division between fraud and not fraud values. This model proved to be way better than the other models and gave us a recall of 96.4%, thus making the model very suitable for our prediction. The F1 score of this new model amounted to a significant 92.7%, almost 50% increment from our previous model. After this, the conclusion is that we realize the ways in which fraud is committed in the real business world. We realize that after every transfer, a cash out is done immediately, and the money is immediately received to the fraudster. It helps us to learn how to deal with an imbalanced data set, as this data set was skewed completely towards the is fraud, and the various techniques that can be used like SMOT and undersampling. This precision model was a great learning experience through the challenge faced while building and evaluating the model. Overall, we would like to conclude by saying that this hackathon was a great learning experience, and we thank you, the organizers and the judges, for your presence.
Done with your presentation?
Yes.
Great. Nice to hear. But aren't you supposed to make some user interface for this?
Yes, the user
Actually, you have to
interface.
present and show, Chris. And Aiden, you have to present whatever you have implemented here as well.
Okay,
You know,
I'll
those
present
judges
that.
will be evaluated.
Yes. Yes.
Yeah. This is the financial model system that we have built in Google Colab. First, we start with the importing of the various libraries. After importing the library,
Eden, sorry, we can't see anything.
1 second.
How are you showing this?
He's presenting his coding Google Collabs. It's just the tab.
Is it visible now?
I can see it.
It's visible.
Okay.
Okay. So after importing the required libraries, we then checked for the data set. We read through it, and we also checked for the. After no missing values were detected, we moved on to the exploratory data analysis. In the exploratory data analysis, we realized that the fraud cases are only 8,000 compared to the 6 million non-fraud cases. Thus, this data set was very skewed towards fraud. The next realization we came to is that is fraud fragged is set to only 16. In only 16 cases, it is set to 1. That is only 0.00.25% of the entire data set. Thus, it was deemed very insignificant for the analysis, and we had dropped the entire column. After that, taking our target variable as is fraud, we came to know that in the various types of our model, cash out and transfer are the two types that are causing fraud. Immediately after a transfer was done, a cash out was done, and that's how the fraud transactions were completed. In the box plots below, it's clearly evident that is fraud happens only in the cases of cash out and transfer. In the next box plot, it is visible that the median of is fraud is higher in the amount category than in the is fraud when it's 0. So this states clearly that the fraud is occurring only in the transactions with the higher amount. Next, we plotted it in a bar graph to make it quite simple to understand, and cash out and transfer over here also depict the is fraud transactions. After this, we created the error and transaction columns. These columns display the error in the data sets. There is a column in the data set which states the balance of the account after it's sending a payment or receiving a payment. These values were mostly not correct, and therefore we had to create an error in transaction to display the errors in these values. These errors and values are very important to the isFraud variable, as our isFraud variable is always close to 0. That means in the fraud transactions, the error rate is very close to 0. In the next scatter plots, it's evident that the error in fraud cases, what I just spoke about, is close to 0. As you can see, it is pointing near and on above and near 0. The third step was cleaning the data. Cleaning the data involved dropping the particular rows and converting the categorical variables into numeric forms. After removing the unnecessary columns, we moved on to the modeling process. This is our first model, XGB Boost model, which proved to give us a accuracy of only actually it gave us an accuracy which was highly overfitted, because of which we had to drop this model. As you can see here, the precision is 99%, the recall as well is 99, and the accuracy is also 99. This states clearly that the model has been overfitted, and this data set is highly, this prediction is highly inaccurate. We tried
What?
to.
Sorry to interrupt. What was the train test split? Yeah.
Yeah, the train test split is a function that we use to split the data set into two parts. That
Yeah.
is one for training and one for testing. So we
Yes.
divided. Yeah,
So what was the split
yeah.
into?
This was an 80-20 split.
Okay. Okay.
Sorry, 70-30 split.
Okay.
Yeah. After that, we moved on to trying custom class weights to increase the importance given to a particular imbalanced class such that the percentage of it in the dataset increases. After giving a weight of 10 to the is fraud cases, we realized that it didn't make a significant difference, and the precision, recall, and accuracy stayed to the overfitted results. Thus, we moved on to our next process, that is undersampling. Here I've created two functions to generate the model report and to generate the AOC ROC curve, AUC of the ROC curve. Next, we moved on to checking the undersampling data set through a raw approach first without changing anything. In that, the recall came up to 42% and the F1 score was 45%. We noticed that this is a very bad model. To better this model, what we had to do was use the undersampled values in our data set. Thus, we created a minority class and a majority class, stating the two different types of fraud, that is when fraud occurs and when fraud doesn't occur. After dividing them into two classes, we then selected them on a random majority indices and assigned them to an undersample data set. After that, we assigned our X and Y variables to our undersample data set, and we fitted the model on the basis of that. We assigned it a random state of 11 such that it does not change the values after a particular model is run. The logistic regression fits the X and Y train, and the prediction of this model resulted in a precision, recall, and accuracy way better than the earlier ones. As you can see here, the recall is almost 96.3%, as mentioned in the PPT, and the F1 score is also 92.2%, which is far better than the earlier F1 score of 42%. The AUC of the ROC curve is shown here, and that is 97%. The UI interface, we have currently not succeeded very much in that. So we have used Streamlit library to build the UI interface, but it faces an error in the data retrieval process.
All right. Fine. Hi, this is Mitch Shah. I have a question for the team. So basically the models that you built, right? The XGBoost model and the logistic regression, you have not done any hyperparameter tuning on it, right? You have just built it with the default parameter value.
You have not done any what?
Hyperparameter tuning.
No. I've just removed the needed parameters, like the needed columns that were needed to remove. After that, I haven't optimized it much on the XGBoost method.
All right. And as far as the training score and testing score of the models are concerned, have you checked for it? Like, because currently the way with which you found overfitting is not the right way to do, right? So usually to check overfitting, what we do is we check the training score, we compare it with the testing score, and that is how we know whether we have overfitting or not. So have you checked the training score and testing score as well?
Yeah, I had done that, but after the accuracy and recall proved to be too high and wasn't what I wanted it to be, I wanted the accuracy to be lesser than the recall, which wasn't the case, and thus I didn't move on that method at all, on that model.
Fine. All right, so that's it from my side.
Also, did you check for any outliers in the dataset, and did you do any outlier treatment?
Yeah, the outliers were in the non-fraud transactions.
Okay,
So
and what was the treatment that you did?
the treatment that we did is when we when we were selecting the undersample data set, it was selecting it on a random basis. So it was not just selecting it from the median approach, not around the median values, but it was selecting it all around. And are generally skewed near zero. as we saw in the box plots.
Okay. But I'm talking about the amounts, like not
No,
but
regarding the
Data set,
amounts
I
column,
think it's pretty common to have outliers in amount column. I was about to ask the same question.
no, regarding the amounts column, we haven't done any outlier tuning.
Is there time for one more question?
Yeah.
Do you think this will work in real life?
This data set was very skewed. So I think with a better data set and with more columns, we could make a better model which would work in real life.
No, this is a real life data because
Okay.
this is anomaly detection, right? It
Yeah.
is supposed to be skewed. Do you want half
Yeah.
the transaction to be fraud?
No. Yeah.
You don't, right? So frauds are thankfully, few
Lesser.
and
Yeah.
far between, right? So this is the data is right. There is nothing wrong with the data. What you have done is you have undersampled. That is fine.
Hmm.
But have you undersampled the test data also?
Yes. The undersampling has been
Then
done.
it won't work in real life.
Okay.
See, undersampling is fine for training data. But if you undersample testing data, that means your test data no longer represents real life,
Yeah.
right? So the accuracy you are getting, you are supposed to get that because you selected your data in that way. But it won't work in actual data. It will predict almost everything as my guess is almost everything as normal transaction.
Correct.
So what I suggest, if there is time remaining, which I doubt, I don't know the format, you should actually sample using some method, uh, some 100 transactions from the original distribution,
Okay.
and then see what happens.
Sure.
Okay.
Thank you so much.
Yeah, but good effort. Adam
Thank you.
and Chris.
Thank you, sir.
Yes. If there are no further questions, I request the team to leave. Thank you.
Also requesting the
Thank you.
judges to fill the form for the same. This team was runtime 10.
Okay, just give us a few minutes.
Yes,
Yeah,
yes.
yeah, yeah. Please let us know when you want the second team to join.
Yeah.
I'm done.
Okay. Other judges, please let us know when you're done.
I'm gonna get the phone.
Yeah, I'm done too.
Okay, okay. Noted.
mine's left. Just a
Yeah,
second.
yeah, yeah. 2 minutes. Yeah. By that time, requesting all of your members to turn on your cameras. Yeah, he's here. Okay, so once again, requesting all of your members to turn on your cameras. So, Team CodeBits, you have 10 minutes. In these 10 minutes, you have to incorporate both your presentation plus your demonstration of the solution to the problem statement. Okay, so your time starts now.
Hello, Ayush.
Yeah, hello.
Yeah.
Good morning, everyone. Good morning, judges and the coordinators. Ija, please continue with the presentation.
Yeah, I started the presentation.
Okay. So our project is on financial management system, and these are our team members. Next, yeah. So the steps involved in our analysis were the first of all the importing the libraries, the data cleaning, making different data sets for the fraud and the flagged fraud. We did this to have a clear visualization for the data. Then we had the EDA, the exploratory data analysis, feature engineering, model building, and then the evaluation of our model. So with regard to the libraries, we have imported libraries for data analysis, NumPy and Pandas, for visualization, Matplot, Libplot, PyPlot, Seaborn and Missingno. Then for the warnings, we have used the warnings library. For the oversampling, we have used the SMOT. For model building, sklearn, and other important libraries for the encoding and the evaluation. So with regards to the data cleaning was our second step after importing the libraries. So initially we got the overview about the data, about the null values, about the info and the description of that. Then we went on with the bar graph to look at what are the null values missing. So with the data set, there were no null values. So with that, we moved on to our next step, which was making different data sets for the fraud and the flagged fraud. So as the data sets were very large, dividing it into two different data sets would have been more meaningful. So we divided the data set into first the flagged fraud and then the fraud cases. Yes. Yeah. Then the exploratory data analysis. For better exploratory data analysis, we drew plots with regard to all the three data sets, which were the original, the fraud, and the flagged fraud. So we found out that only 0.13% of the data sets were under the category of the fraud, and 0.000252% of the data sets were the flag fraud. So also with this visualization, we were having a visualization of the step as with regards to the step, how the raw data and the flagged and the fraud data changed. We found out that after the 400 step, the normal transactions reduced, but the cases of flagged fraud increased while the cases of the fraud were as usual. Next page. Yeah, same description. Next page. Yeah. Then with regard to the fraud transfers, we saw that almost all the transfers which were fraud were either of and they were equal in cases. I think one page back. Take it. Yeah, so this was the pie chart which we used for the representation. Next page. So while exploring the amount of columns, we found out the most of transactions that took place was of the maximum amount, and the maximum cases of the frauds were also with regard to the maximum amount. Also with regard to the name of the origin and the destination, we found out that none of the accounts which were of the destination merchant were of fraud, and all the name origin were unique in the fraud cases, while the name destination, there were 22 cases in which the destination or address, the destination ID of the fraud was same. And our last part of the visualization was with regarding to the correlation between the data points. To the next column, next page. Yeah. So with regard to the correlation, we found out that the new balance origin and the old balance origin were highly correlated along with new balance destination and old balance destination. So we used this point for the data cleaning. And next, Teja may continue.
Yeah, that part of the here is future engineering. It has the most abundant use of future engineering. Now, first of all, we have started with the future selection. The name, origin, and name test will be having the unique values as the being the account details like that. So we have removed those. After those, we have gone into the future extraction. We have considered the two variables error, new amount minus old amount, so that we can make a prediction or try a guess of it whether it is false or not. Next, we have gone to the future encoding. As the machine can learn from the numerical data, we have used one hot encoding like pt.get dummies. We have also removed a column in order to avoid the dummy trap. Also, we have 5 categorical features, so 4 will be created, and we are in the data set. We will be handling the data set. Initial class distribution was 6 million are non-fraud cases and 8,213 were the fraud cases. Now we have went to now after smooth oversampling, the class distribution was we have used sampling strategy equals to 0.4 so that there would be increase in fraud cases to analyze it. And next, normalization. While we are applying classification algorithms, we have applied total 3 algorithms, namely first one is the logistic regression, second one boosting algorithms AdaBoost and XGBoost. AdaBoost are having the decision trees of unit stem, one split. These are called decision stubs. So for the logistic regression, as it is distance related, we have used the min-max scalar to avoid that. And we have built models, and this is the evaluation of our model. And this is the app we deployed using the Streamlit and the joblib file.
Teja, we have also cross-evaluated our 3 models.
Yeah.
We first splitted the model into 25 test set and 40 and 75 training set. Then cross-validated it using 3 model XGB, AdaBoost, and logistic regression. Then we found that XGBoost was giving a much higher score than other. So we trained our training data on XGBoost and saved the model using joblib.
Yeah, I'm showing the Streamlit app we have built. This is the Streamlit app. Also, we have made some constraints according to it. What is the step is nothing but it has to be greater than 744. But if you give 800, it says it should be less than 744. Like that, we have given the constraints according to the user input so that we can find whether the transaction is fraud or not. Like this is our file we have built. Like first of all, we have continued with the data cleaning part, and this is the small analysis of the data, like how many rows and columns, data statistical measures, and we get into the data cleaning. There were no null values, so there was no record of data cleaning in it. Now we have shown same visually also using missing no library, and we have analyzing each column in the data, and we have started the EDA also simultaneously. And these are the plots we have seen in the presentation also. And we have making some useful points in using this. Yes, this is the correlation map we have built. Select the futures according to it. Also, we have few future engineering topics, like few have not done, like outliers, because as it is the fraud detection app. Let us say we have a 25 crores amount of transaction. If it is fraud, if you remove those rows or records, the model we have built will not be robust. So we have not touched the outlier concept here. And we have done the encoding parts of future engineering. Remaining parts of future engineering were done here. These are the 3 classification models we have built. And the final one is the classification report. And we have build the model using joblib. Hello.
Is the presentation complete?
Yes, the presentation is complete.
So I have one question for the team. So while building the models, have you used any of the feature selection techniques?
Feature selection techniques, sir?
For example, for logistic regression model, you could have applied feature selection techniques like RFE, VIF. There are many other feature selection techniques. Have you used any of the feature selection techniques?
Yeah, also some of those as this is a long data, we cannot apply future selection techniques like forward elimination and forward selection and backward elimination. Also, missing values are also not there. We cannot apply that also, and we are having a variance. And also, based on the data and the, I mean, correlation, we have removed some of the columns and we have extracted the remaining columns.
But if you can name one feature selection technique that you have applied. Fine, I understood. You have used the correlation. Based on that, you would have removed some feature. Apart from that, have you used any other feature like RFE gap?
No, so we have not used any other future selection technique for that.
And what about the UI? I guess you guys are supposed to build UI, right?
Yes, sir.
Yes, sir, we have built.
Can you test it right now?
Yeah, I can test it. Let us say I'm taking a fraud case here. Yeah, 743 cash out and the 743.
Change the type of transaction.
Yeah, okay, cash out.
Teja, can you just go back to the UI once?
Yes.
Yeah. Okay. What is the value in the enter? Enter the name origin. What is this exactly?
Sir?
Yeah. What is this value exactly? The name origin.
It is the
Name
ID
origin is
of
nothing but ID of the person of the transferring, like whatever the type of transaction account is, the person of the one
Do you
one
think this
point.
ID is relevant when we are training the model, like the ID of an individual?
Sir, we have not involved this in our training also because it will be unique for each, right?
Correct. But it's part of the UI, is it?
Yeah, it's part of the UI.
Bro, you need to change the amount.
So I have a question for the team. So you are saying that name origin is not involved in training the model, right?
Yes, sir. We're not involved. Let me show you that.
Why
also.
is it involved in predicting then?
Yeah, we have involved in the UA because it was having an importance of future what I have given in the data set. Whatever the data frame we are passing to predict, only we are passing the useful attributes like whatever the columns on which we have predicted our model. Only
In
those
the
columns have.
problem statement is what it was asked to enter it.
Yeah.
No, whatever features you are training your model on, ideally the same should be the input even in the UI.
So actually, we thought that if there is any chance, like if anyone is gonna store this data, so it can be more helpful. Like if we have all the details which were mentioned.
Okay.
Also, it has been mentioned in the rules that while typing the ID, you have to create an ID for the UA. It has been mentioned in the rules, so we have considered those columns. But we have not included it in the data from predicting.
So one for the team from mine. So you said that name origin is not involved in training the model, right? So
Yes.
Can you show to me the code right now? Can you just show to me that what all feature columns were used in training?
Yes, sir, sure. Yes, sir. These are the columns we have used.
You train the model on X train and Y train, right? So basically, X train would contain the features in your training data.
Yes, sir.
Can you
Yes, sir.
Find out that what all features do you have in your training data?
Yes, sir. These are the features in the train data set. Except the is fraud column, we have all those features.
This is your, I think this is your entire data set, right? This is
No,
not
sir,
your
it not
data
entire
set.
data set. Entire data set is having.
I'm asking about X will contain your features in the training data set.
Show the location, Teja, where you have like written for the X string and the X test.
Yeah. So this is the external extents. We have not included those in our data.
Is it possible that in X train what all feature columns were used? Can you print that out?
Can you run that extreme?
Yeah, I can
I
run.
want to see in X
But
train what all feature columns were.
yes, yes. It was running.
Ayush, can you show it?
Yeah, can you show it? I have changed the location path. Shreyas or Ayush, can you share the screen?
Guys, 15 minutes are over. Please wrap up quickly.
Yes, yes.
So till the time is coming up with the screen, I had a question. So you came up with some feature engineering
Yes.
features, right? So have you like seen what use that feature had in the final prediction? So let's say the feature was basically subtraction of the original amount minus the destination amount, right?
Yes.
So what was the trend of that particular feature in predicting the final output?
Yeah, we have built the heat map for it, whether to its correlation, like whatever the amount we have sent to the destination, is it received or not, we can be checked by the new balance minus old balance, right? So we have built a heat map to correlate it. So if it's highly correlated, then we have, it's not a fraud case. But it is not correlated means we have it is a fraud, we can say, according to that.
Okay. Okay.
Ayush, can you share this?
Just a minute, I'll try.
Teja, you can show that in Streamlit app what features we are predicting with.
Yeah, yes, I have a stream it up. Sir, these are the features we are predicting. Type, step, name origin. We have just taken the name origin as for the, I mean, it was been changed. Wait a minute. Yeah. Start checking this. Yeah. The step, amount, new balance origin, and the new balance dest, and the new balance.
Your screen is not visible, I guess.
Guys, I guess you'll have to wind it up because it's going more than 15. It's almost 20 minutes now.
1 minute, ma'am. 1 minute. Wind up. My screen is visible, right?
Yes.
Yes, sir. This is the job file we have created, and the step. These are the we have used the one hot encoding on the column of type. So type cash out, type debit, type payment. So and these are the error log and error dash. Based on this, we have predictor out model. I hope it's visible, sir.
Questions are from me.
These are the features we have used for predicting.
One final question, like did you do any kind of hyperparameter tuning?
No, sir, we have not done any hyperparameter.
Okay.
Sir, we just balance weights. That's it. Class weight equals to balance.
Balanced.
That's it from mine.
Okay, if there are no more questions, please, team, you can leave.
Okay, thank you.
Thank you, sir.
Also, judges, this is Steam code bits.
Yeah.
I'm done this time. I already given.
Okay, noted.
There are 5 teams, right? You know.
Yeah.
I'm done with the scoring as well on the form.
Okay.
So the final selection will be automatic based on the marks, or are we going to have some deliberation?
Y'all can have a talk. We'll calculate the score and let y'all know. And again, y'all can have a discussion on to whether, because after seeing the 5 teams, again, y'all will get an idea. Maybe this was much better than this.
Exactly.
So
Yeah.
y'all can have a discussion in the end.
It's relative, no? After all. So
Yeah.
also, there are 3 prizes, correct?
Yeah, 3 prizes.
Yeah, I'm done as well.
I'm also done.
That's all, I guess we can.
Admitted the next team. Okay, so the next team is Arcarius. Are all your members here, Team Arcarius?
No, one more member is coming.
Okay.
Guys, you all have 15 minutes, 10 minutes for a presentation and 5 minutes for the Q&As. So keep up the time and all the best.
Yeah, so we'll begin now.
Yeah.
So good morning, one and all. We are Team Arcarius. You are at ID 5. And the problem statement which was given to us is to create a financial fraud detection model based on the data sets given to us. So this model, we'll have to train it on the set of the values which are given. It has around it has around 10 columns, and each has its own significance. We are supposed to give in the first the name of the origin value, that is the transaction ID. Okay, and when we pass that, the model should itself learn and tell us, predict whether it's a fraud transaction and not fraud transaction, and it has to print the old balance of the origin, new balance of the origin, amount, and the destination. So first, basically, after loading the data, we had done a self-analysis. We were checking for which all columns have played a significant role, which all could be considered not included, as there wasn't much of a contribution to the fraud values. And we were also checking the data types of the column so that we can pass it around while using, and if there were any missing values or unique values in the data set given. So box plot graphs we had used for checking the relation between the fraud and the step. Box plot we basically use because it also gives us the minimum and maximum values, whereas it also tells us the percentile, like quartile. The first quartile is the lower of the rectangle, lower part of the rectangle, then the median, and then the upper part is the top 75th percentile mark. So what happens here is we get an idea of the density as to where it is that particular is fraud is happening more, the occurrence of is fraud is more and more. So from here we understood that only out of the 5 types of transaction given to us, only 2 of them were giving us fraud. Like only 2 transaction activities were fraudulent, were of the fraudulent types, had fraudulent activities in them. And then for is flagged fraud is basically a condition where if the transaction type is more than 200,000, it will automatically mark it as a flagged fraud. So, and we also found that if in the total, out of the total 6.3 million rows, only 16 of them were marked by the is flagged value, whereas 8,213 were actually fraud. So now we understand that this fraud condition isn't targeting a lot of fraud values, and it is not able to identify it on its own.
Also, out of the fraud types that were there, that is transfer and cash out, only the transfer frauds were flagged, or only transactions of the transfer type were flagged as fraud, and the cash out ones weren't detected.
So we tried and went searched around the data for different conditions. We tried filtering them and all. So we found that in total there were 8,213 fraud. Now we applied one condition of our own, and we found that this pattern was able to identify, this particular condition was able to identify 8,034 fraud values out of the 8,213. That is around 97% of the fraud values this condition was able to detect. This condition is basically that if the amount of the transaction type from transfer and cash out, if the amount is equal to the old balance of the origin, that means the fraudster is trying to empty the old balance origin account, and hence it marked it as fraud. So, and then we found that around 179 weren't included in this condition. So we tried to analyze on those 179 fraud values, and we found that out of the 179, 154 were of transfer types and 25 were of cash out types. From the 154 transfer types, the one thing was which was repeating again and again was when the amount is 1 into 10 raised to 7. That time, 145 of the 154 transaction types were transactions where the amount was 1 into 10 raised to 7. That's a huge amount. And the 9 was some random list which we weren't able to understand. And in the 25 cash out types, there were 21 where the new balance destination and old balance of the destination was 0. So those weren't affected, and these we found there were 21 values and there were 4 random. So this is what we understood from our own self-analysis on the data set given to us.
Right. So then, after looking around a little bit and doing a little bit of research on how to train our model and which model to use, we decided on using the XGBoost XGB classifier. So the XGBoost applies better regularization technique to reduce the overfitting, and so that's one of the key differences. So initially, we started off using Cat Boost, but then we realized that in our data set, we have majority of the values are numeric, and so XGBoost works better with those numeric values, and hence we migrated to XGBoost classifier above the Cat Boost classifier that we were using earlier. So now this is our original data set, all the list of columns that we have. And then, so we checked the data types of all the columns. So over here, when we checked the data types of the column, we came to know that the type, that the rest of them were in numeric values in int or float, but the names and the type name, they were objects, and those could not be or weren't fed into XGBoost properly. And so that's why we realized that the names of the customer and the name of the origin and destination did not play a very big role in the training of our model, and hence we dropped those fields. Also, from the ADA, we saw in the box plot that the fraud cases were occurring only when the transaction type was transfer or cash out, and hence we consider only those two payment types for the training our model. And then so because type was an object and we need to convert it into a numeric value, we use this over here to convert transfer into zeros and cash out into ones, so that we can pass it into the model without any problems.
We also realized that the XGBoost classifier, since it only understands numerical values, if the data types of the variables that we have are anything else other than the few things that it understands, then it throws up an error, even if it is like a null value. So we had to go ahead with the data processing because of the classifier. So that is why we have used, as you can see here, the replace function for all the types, and we have used that for all the other types later too when we were trying to pre-process the data and present the data on our
when we
GUI.
implemented the final model for the application. So then here, so we observed that many of the amounts that were there, as Ryan said earlier in our preliminary, when we were trying to understand the trends in the data. So we observed that many of the amounts in the transactions were not matching up with the difference in the new balance and old balance of the accounts. And hence we decided that it would make more sense for us to add a flag of our own to the data that we have, which we called error balance of origin and error balance of destination, which basically is the difference between the new account and the like the new balance and the old balance. Then this was our new data that we had eventually, where you can see the type is either transfer or cash out, where transfer is 0, cash out is 1. So they're all in numeric format, and hence we can pass it into the XGBoost without any problems. Then we created our feature and label pairs. So over here, Y, so we took is fraud, the table is, the column is fraud from our data. We use that as Y or as our labels. And X was we dropped is fraud from this list of data that we had. We dropped the is fraud table and we kept it and we passed it into the XGBoost. Then to reduce bias, so we can see that the bias between the fraud cases and the non-fraud cases is very large. The transactions that aren't frauds is 99.8709%, and the fraud cases are only 0.1291.
So like in every 774 transactions, only one fraud transaction is happening, and that is a huge difference between the ratio.
So we used undersampling. So we considered oversampling and undersampling to make them the labels more proportionate. So we decided against oversampling because then we'd be creating our own synthetic entries into the data, and that didn't make sense because we'd be tampering with the data set. So we decided with undersampling, so where we'll be reducing the amount of non-fraud labels to make it more proportional to the to make it more proportional so that our to reduce the bias.
Because if we train on that model without undersampling, what will happen? Suppose we are taking 70-30. Well, even if the 70% of the data values which we are giving is not fraud, and when we train on a fraud, when we predict on a fraud value, it might give not fraud with a high accuracy also, because as you can see, only a few values are.
Guys, sorry to interrupt, but if you all are planning to show your implementation, do hurry up. So almost 10 minutes done.
Okay.
The judges need to even see your implementation, so just the PPT
Yeah.
will
Yeah,
work.
yeah.
So please hurry up. 10 minutes is already up, so hurry up.
Okay. So we split the data using a 70-30 split between training and test data, and then we evaluated it using the confusion matrix and our scores. Now I'll show you the web application that we created. So I've opened it over here.
We used Flask
Right. So we used Flask and we created a model from using Pickle.
So basically, in our backend, we've used Flask, and Udhar we have put our model. So whenever we put our transaction ID through the website, it goes and runs the transaction ID through our model and gives us an output and tells us whether the given transaction ID is a fraud or not, along with the old balance origin and the new balance origin, and the name of destination where the transfer has occurred and how much was the amount. So Neve will show you how it works.
So according to our problem statement, we had to take the transaction ID as the origin account name. And so if we take the origin account name of this particular transaction and we submit it in this, it pulls up the data from here, passes it to the model predicts, and it says that the transaction is a fraud. So now it had already been in fraud, so I'll put one that is not fraud. So if we choose this one here, which is not a fraud value, and I pass it into the into this over here. Wait, let me run this again.
Just a question from my end, like, shouldn't we have fields that we can input from our side rather than pulling the data from the data set itself and then showing what the
So
model is already
basically,
trained?
according to our problem statement, they had asked us to load in the CSV and put in just the transaction ID. But like you said, we have different columns that we can add into, for example, like how much amount is being transferred from which account and to where, right? So we can have those things put up on our GUI, which will then run those values on the backend using the model. And then it will tell us whether it is a fraud or not.
Okay.
Yeah, I had one more question. So basically, in order to predict, you are just taking transaction ID, right? As in, what about the other features?
Yeah, in the backend, like
No,
from
so
the input.
what we're
Yeah.
doing over here is that we take the transaction ID as the customer name of the
Input.
origin, right? And then we search in the CSV and pull up that row. And then after we process that as we passed it into the in the model. We process it in such a way, and then we pass that row into the model to predict, and we take the prediction, and based on that we decide whether it is a fraud or it is not a fraud.
So then it could be the case that, yeah, the model that you are trained on, right? The data that you are trained on, that data could be an input to this model, right? And that is not how it should be. Like the training model, the training data shouldn't be the data with which it is tested.
Yeah. So when we train the model and before creating the model file, that time we split the data into two parts, into training and testing. So over there we use that to check the accuracy of the model. But eventually, when it gets deployed into the real world, there could be similar cases to which it occurred inside of in the phase when it was training. So then it should be able to act over the whole data set. That was what we thought about. That was our logic. That it should act over all the 6 million cases inside of the data set, and not just the test or the training.
No, in real world it would be beyond the 6 million. Like,
yeah,
it wouldn't be any of the 6 million, but apart from the 6 million.
Yes, I have one more question. So basically, you guys implemented the XGBoost model, right? And you said that XGBoost would be better to prevent overfitting.
And for numerical values.
Right. So as you said, XGBoost is used to prevent overfitting. But did you try out other models as well? Like let's say decision tree, and see if in decision tree I'm getting overfitting, and then move on to XGBoost, or you directly move on to XGBoost?
We went with cat boost first, and then we like did some research on those lines, and then we seen the different classifiers in the that we have for options, and then we decided to go with XG boost as a classifier.
Because our sample data set is mainly numeric values, and XGBoost works better with numeric values, and hence we decided to go with that.
Yeah, but the initial graph or the diagram that you showed, where you had segregated each of the columns, and based on the columns, you were saying that, yeah, if I put this filter, 8,023 cases are already. Yeah. So that approach follows more of a decision tree kind of approach. And maybe
those were trends that we was trying to
what we understood.
And because you understood that, you should have kind of gone from the start, from the base, like use a decision tree model, then try a random forest model, and then go and then build upon that, rather than directly going to cat boost and XGBoost.
Okay, you should have put that point. Like this domain was also a little new for us. We thought we thought we could add some if conditions to the model itself, like depending on the flag value, then we understood that it's not as easy as it seems for us as
So that's why we added that extra
algorithms which are
extra two
available.
columns to the
Yeah, but that analysis, that initial analysis was very good.
Thank you.
Yes, I have one last question for the team. Have you guys implemented hyperparameter tuning and feature selection techniques?
Sorry, can you repeat the question?
Yeah, I was asking, have you implemented hyperparameter tuning in your model?
No, sir.
What about feature selection techniques like RFE, VF, like any other feature selection technique? Have you implemented it? Feature selection techniques.
No, sir.
No, I guess we haven't done that.
Fine. Your EDA was very good. Because that uh, your modeling your modeling needs to improve. Okay, but the EDA was good. The modeling needs to
Okay, yeah, thank you.
Yes, sir. Thank you, sir.
If there are no further questions, I'd like to request the team to leave the meet. Thank you.
Thank you.
Thank you.
Thank you.
Judges, let us know when you're ready.
Yeah.
And judges, this was Team Arcarios, just to be clear.
Right. Okay, I'm done.
Yeah, I'm done too.
I'm also done.
So, judges, the next team is here. Bella Ciao. Requesting the members of Bella Ciao to please switch on their cameras. Thank you. So, Team Bella Ciao, you have a total of 15 minutes, out of which 10 minutes are for you, wherein which you have to incorporate your presentation plus your demonstration of the implementation of your solution. And the later 5 minutes are for the judges to ask questions.
Okay. So hi. Yeah. So hi Judy. We're a team of 4 belonging from Bella Ciao, and today I'll just start up with taking you through all the points and the insights that we gathered through. Once, if you could tell me if my screen is sharing and it's visible.
Yeah, it's visible.
Yeah, so the framework, let's start with the framework. For front end, we use React.js, and for machine learning, we use certain libraries like XGBoost, sklearn, NumPy, Pandas, and so on. For backend, we used Flask, and the deployment of backend happened on Azure, and front end was on AWS. Now, coming through certain observations that we saw were, so in normal transactions, we found out that between 11 to 21 hours, most of the transactions, safe transactions took place. And in fraud, there were 2 parameters, cash out and transfer, that stood out the most. And rest of the KYC and other things, I'll explain you in the action plan later. So this is our another model, which tells us that on the basis of large transactions, the frauds were not directly correlated, whether it was small or a big amount. Coming next here, there is again a plot of that shows that amount and the hours. It does not depend how bigger the amount is based on the hours. There was, we'll say, a weak correlation between the two parameters. Now, coming to feature engineering, so we created new features, that is the error in the transaction amount, which was the difference in the actual transaction amount and the difference between money sent and received. And we saw that this new feature had the highest correlation with the fraud. Coming to this plot here, it shows that the fraud which happened at random times were a good indication of alerts, and the amount was weakly correlated with the fraud. Coming to error metric, recall and EUC curves, we chose error metric as recall as we want to go with minimizing the cases where machine predicts a safe transaction, because it might hamper with the UX, but we want a safer model considering at this moment in comparison with the speed. We wanted the model to perform better on true negative cases, as false positive cases will only hamper the experience, but true negative ones will cause a loss of money. So we divided the data into 80-20 as it was given in the paper. So this was the ROC curve. And coming to the confusion matrix, so here as we can see, to minimize the value 3 that we see here, as that is what we tried, as when the machine would say that it is not fraud while it actually is. So we try to reduce that number 3 here. Talking about model selection, we selected XGBoost as it handles imbalanced data very efficiently, and you do not need to feature scale it. And then we move forward with one-hot encoding and using which was used for cash out and transactions when we talked about CAD Boost and other models like LGBN. One of the things was that, that provided speed, but at that point, it was not our main goal. Now, coming up to that, why not sampling? This is because the real world data is skewed as well, and XGB will be much better options here, which handles unbalanced classes very efficiently. This is one thing that we observed. I think we talked in past sessions also, that A to B to C hypothesis, that we saw that it was that this hypothesis did not stand true, since most of the IDs were unique in itself. Now coming to talking about the destination accounts, we saw that the transaction and the new balance of the destination is 0. So we can consider them as fraudulent transactions. And this happened on 0 original balance accounts. Coming to origin, fraud transactions mostly happen on accounts which had initial balance. We can keep a check on those accounts. The conclusions that we can derive from all this is that we need to keep a check on balance accounts which are 0, relating to transfers and cash outs. And here we saw that in original balances, there were high and random, but in fraud, the old account balances changes to 0, and the target account also changes to 0. We saw that more transfer transactions were flagged as fraud, cash out transactions were comparatively not. So this is our plan. I'll take you through a quick look here. We decided on our action plan was that first we'll provide authentication in any form, security questions, KYC, OTP, and anytime it raises an alarm. So alarm can be raised when either of these cases are true or multiple cases are true, when any abnormal transaction takes place out of 11 to 21 hours gap, and then if the user is transferring all the amount to another account which has balance 0, so then also an alarm is raised. Coming to last point, we could add extra authentication in it through biometrics, which we also know is also linked to our Aadhaar card. So it would make the transaction process much safer. So other improvements we could add on is that blockchain we could do so we know from which account it is being transferred to which target account, how much amount, when, and so it all happens in a safe way. Another improvement we could also add is blocking the suspicious IP addresses which we feel the transactions are not safe enough. So thank you. I'll just forward to Ved. Ved, if you could please continue.
Yes, thank you, Khushbu. So I'll just show a demonstration of the website that we had used to implement this. I've also shared a deployed link in the chat box for your reference. Just excuse me for one moment. Could you let me know if my screen is visible?
Yes, it is.
All right. So again, in this, we have a simple landing page over here that is describing what exactly our product is. Coming to the get started section over here, the user will enter his transaction ID, and this is the section which will show the percentage at which fraud can occur. So given the fact that there is no transaction ID input over here, currently it is at 0. But say if I were to input a transaction ID here, it takes a little bit of time to read the data. So yes, so all the data from the transaction details have been fetched. So this is for the payment process. If I were to take another transaction ID, say for transfer, you can see fraud detected over here. The number given over here, it is at 100%. Actually, the data that is being returned, it is at around 99 point, it is a value a little bit greater than 99. So we have rounded it off to 100% as it is easier to take up whole numbers. So this was a demonstration of our implementation for in website form. I would like to hand it over to Ritik to show the notebooks.
Yeah, thank you. Now, please let me know if my screen is visible.
Yes, it is.
Yeah, so I have done the firstly the UI UX part of the website. So these are the Figma prototypes I've done, and then moving on to the notebook. Yes, so first these plots are already shown in the PPT itself, and then we found out that only transfer and cash outs were fraud, and other by comparing the value from the data frame, and then we use the one hot 10 coding for the transfer and cash out types, and then we actually handle the anomalies like the new balance is 0, old balance is 0, but the amount is not equal to 0. That is an anomaly that we handled in this. And we created new parameters of errors. Okay, these are the new error in the destination and error in the balance of the origin. Then we splitted the data set and used AUPRC for the accuracy precision, and trained it on XGB classifier. As mentioned, it handle as it has 0.03% only as the fraud, so it is highly unbalanced, and XGB classifier handles it well. We have also, for hyperparameter tuning, we have also tried a random search grid CV in the another notebook, but that was taking a lot of time, and due to the time constraint of the hackathon, we have to stop running that cell, and we
Sorry to
settled on.
interrupt, but Team Balacha, your 10 minutes are over, so please wrap up fast.
Yeah, okay. So the notebook part, in here I plotted the confusion matrix. So moving on to Aman.
Yeah,
You want-
I'll present the Flask app and I'll show it to you in just a minute. So basically, for the Flask app, we were the time which was the Flask app was taking was basically due to reading the data, which was a like which was a very abnormal issue because the model is taking lesser time compared to like just reading like pd.read CSV is taking more time. So we kept small amount of data which was like put on the cloud because every time the function is that pd.read CSV has to run. So we put 10% last 10% of the data there. So basically this is what is happening. So this was the Flask file and we basically take the IDN, put it into the dataset, like query in the dataset, like pick out all the records associated with it, and then transform it according to the format which Ritik showed you right now with the anomalies and everything. And then we put it into the model which predicts the like the probability. And as Ved said, like the amount of the the percentage is 99.9 something. So basically that is coming through the like API. If you want, we could show it to you. But I mean, that's the thing that's happening out there. And yeah, I think this is it for the backend part.
Yeah, and where is this model deployed?
The backend is deployed on Azure and the
Okay.
front end on AWS.
Okay. Why two different cloud services?
So
I had a question. So, I mean, good work that you have gone beyond evaluation, compared to the other teams. You have taken a step ahead and gone beyond evaluation and you have deployed the model as well. Very good on that. And good work on the PPT as well. So, just out of curiosity, why have you chosen two different cloud platforms?
Okay, so first of all, we were planning to go with Azure, but we were having some issues with like pushing it to GitHub, and then like even if you don't push it to GitHub, we can use Azure Static Web Apps for like the front end. But the issues what that we were facing were actually I think Ved could explain the front end issues.
I mean, they were quite anomalous. They were strange errors. Like when we were trying to deploy it with Azure, it was not allowing us to create the static app. And for some reason, I mean, even when different services like Netlify and Heroku, it wasn't working. So we tried it with AWS and it worked.
Yeah, and when we tried with AWS, so it worked. So we had different.
But the backend was already deployed a few hours ago on.
Yeah, as soon as you build the model, so we deployed the backend. So yeah.
All right, makes sense.
Hi, great work, right?
Thank you, sir.
Yes, sir.
The question is, so who do you think is your user, the product that you have created?
I think maybe the company or the merchant, like someone who is overlooking the transactions. Like if you can consider a bank. So if a bank has these records like of the different transactions happening within it, so maybe the bank would be like in charge. Maybe they could
While the transaction is happening.
While a transaction is happening, then also I think like if the transaction goes wrong, then the customer will complain to the bank, right? So the bank is maybe held in charge, or like the assets of the bank are.
Right. So the bank is you're going to use your product, and bank's customers are going to do the transactions.
Yeah.
And as the transaction comes in, your system has to run before the transaction is made, right? Okay. So do you think the UI that you have made can be actually used?
No, actually the UI is for this prototyping thing
For
because
demonstration. It's fine. But do you think it can be used actually?
In the real world, we do not have to enter the ID like this. Instead, it will directly go into the backend and it will display us the results.
So how will you offer your product to the bank? In what form?
We can offer it as an extension to their already existing softwares, like whatever we don't have in inside knowledge of what softwares banks and all use. So we can offer it as an extension instead of separate.
So
what about as an API?
Yeah, the term would be API actually.
Yeah. So yeah, I think we can do that, and like because mostly it's one API which is running. Like the whole front end is based out of one API. So yeah, I guess when you enter a transaction, when you but like we told you about all the details in the PPTK, the time and everything. So maybe then the alarm could happen, and then we could like raise an alarm, or maybe depending on the relationship with the bank, if they allow us, we can also go for making the front end or the back end or the two-factor authentication or anything, because nowadays Firebase is a very good option for OTP and pretty much every security authentication. But like right now, due to the time constraints, we were not able to make another portal for like showing everything.
Yeah. Great. Nice work.
Thank you.
Thank you.
Yeah, so if there are no more questions, I may ask the team to leave the meet. Thank you.
Thank you.
Thank you.
So
Thank
much.
you.
Have a good
Thank
day.
you.
Have a good day. Thank you.
Yeah, so what was this team's name?
Bella Ciao.
Okay.
I'm done.
Okay.
Yeah, I'm done too. Next is the last team that we have, right?
Yeah, next is the last team.
All right.
I'm also done.
Okay, okay.
I'm done.
Okay, so I'll call the next team in, right?
Yes.
Team Hackathon pitchers are all your members here?
Yes, everyone.
Okay, so team, you have a total of 15 minutes, out of which 10 minutes are for you. That is, you have 10 minutes in which you have to present your PPT plus your demonstration to the judges. After that, 5 minutes are allotted for the judges in which they will be asking you questions. Am I clear?
Yeah, clear.
Okay. So you may start now.
Yeah, I'm sharing a screen. Just a second. Is my screen visible?
Yeah, it is visible.
Greetings to everyone, participants, jury, and the organizers. We are Hackathon Pitchers. I am Jay Bhanushali.
I'm Akshat Gabane. And I'm Prachet Shah.
A problem statement is to detect frauds in a financial management system using the dataset in which there are transaction IDs, debit, payment transfer, etc. A plan of action is to first understand the problem statement well, on which following which we can do EDA to understand the data set very well. Then we build the model. That is, firstly we find all the models that could be used, test several models and find the most appropriate one. Finally, we build the website, deploy the model in the backend, and we can also deploy the website as well. The models that we could use to optimize the solution are decision tree classifier, logistic regression, neural networks, random forest, SVM, and other classification models. Over to you, Akshay.
So from all these algorithms, we chose the decision tree classifier because it well suited our model. And as for the libraries used, we've used scikit for training the model. We've used pandas for handling the data. We used pickle for exporting and importing the model, and matplotlib for plotting the graphs. Next slide. As for why we didn't use neural networks, that's because it's very slow and there were time constraints in the hackathon. And as for why we used decision trees is because a machine learning algorithm is much faster and it gave us a better recall and precision value than any other classifiers.
So over to feature selection of our data. So while analyzing our data, we took into account some columns like step, name, destination, type, and is flagged fraud needed to be changed for our training purposes. So the column step was basically the 3-day simulation based on hours. So there was no need of applying it to the training. So we rejected that model. Name destination was also a string which had no other significance while determining the correlations. The column type was very significant, and we found out that only 2 columns out of the 5, only 2 rows only 2 types of transactions out of the 5 types were having fraud transactions, and other 3 did not have any fraud transactions. So we basically label encoded the type column, the type of transaction, and we table encoded them into this way to apply our model into training. And the second part, the second challenge we faced was balancing the dataset. As the dataset was large, it had around 62 lakh rows and 12 columns. There was very little fraud transactions compared to non-fraud transactions. The fraud transactions were around 8,000 and non-fraud transactions were the rest. So we decided to downsample the type which had fraud transactions, that were transfer and cash out types, which had the total all transactions of around 8,000. So we decided to downsample it into ratio of approximately 1:1. So there were less chances of overfitting, and we can get more recall and F1 score with that. We also calculated some fields with it. So these are the results and metrics we got by applying training our model on different types of classification algorithms. The best one we obtained was with decision tree classifier, and therefore we decided to go with it. So now we will also go to the EDA part of it, and thank you all for being a patient audience to us. Jai, if you can stop. Is my screen visible to all?
Yeah, it is.
Yeah, okay, thank you. So basically, after importing the library, we took the dataset which was provided to us. We can see that it had around 63 lakh rows, which is a very large dataset. We found out that if it had any none values, which we found that there were none. So we are good to go with that case as well. Then we found out the type value counts of different types of transactions which we had. We found out that number of frauds were only there in cash out and transfer type of transactions. So what we did is that we segregated the dataset into cash out and transfer only, and we created new dataset for that. So for cash out non-fraud dataset, we had around 22 lakh, and for around not fraud transfer, we had around 52,000 rows for that. And for fraud and then we downsample it to around to meet it to 1:1 ratio with the fraudulent transactions. So our overall data while by concatenating this came to be around 16,000 rows with 11 columns. Now, after this, what we did is we did feature selection and label encoding. So what we did is that we label encoded the type of cash out and transfer and gave it a value of 0 and 1. Then what we did was name origin. So according to the problem statement, we were told that we were to input transaction ID, which was basically the name origin. So what we did is that we took this into consideration and we removed the first C from the data and pass it to model as well. We decided to remove the name destination and is flagged fraud from this as well. And even the step column was decided to be dropped off. Is flagged fraud is decided to drop because it is something which their model, the financial systems model has predicted, and this is what we have to predict. So this is the label encoding part. Yeah. So then after removing the C from the name origin from the start, we then converted into numeric data so we can pass it to training. Yeah, then we assigned its values and put it into training. We decided to split it to 75% trained data and 25% test data. And then we trained it with different models like logistic regression, which gave us an recall of 85 and F1 score of 89. We did it with SVM as well, with similar scores, and naive Bayes as well for Gaussian determination, but this also gave us very low recall and precision scores. Then finally, when we came to decision tree, and you can see this, it has a max depth of 25. We did some hyperparameter tuning here as well. We found out that the n estimators which works here is the best are 25, and Gini entropy won't work here as this is a binary classification model. So entropy criterion worked here the best. So this is our decision tree graph. It gave us a recall of 98.8%, and it is basically giving us F1 score of 98% as well. Similarly, for random forest and kernel SVM, we tried it as well. So this was basically the model analysis which came when we trained the data first. It is a little bit fluctuating now because we downsample it in a random basis. So it fluctuates somewhere around 98.8 and 99.2. So this is how we predict our single outputs from here. And for exporting our model to the backend path, we are using a Pickle library. So what we are doing is that we are exporting our decision tree classifier as a fraud model, and then opening it in the Flask backend, which we have used for backend, and Tailwind, which we have used to create styling and create our UI. So now I'll pass it over to Akshit to show us the backend and front-end code, and also show you the UI of our code, which we are yet to deploy, and we will do it soon.
Just a second, I'll just share my screen. So I hope you can see my screen.
Yeah, it is visible.
Yeah. So this is our fast app, which applies Tailwind CSS for styling. Is it visible now?
Yeah, it is visible.
Sorry to interrupt, but
yeah.
your 10
So
minutes are
basically, we're
over,
taking.
so just wrap up quickly. Thank you.
Yeah, sure. So we just input the transaction ID, and when we submit, we get a table which shows all the information that we've grabbed from the CSV files, and it also shows whether it's a fraud or it's not a fraud. So just for demonstration purposes, I've got some values over here. So from the data set itself, I've gotten some values which are actually frauds. So let's just take this value and submit. So when I submit, it grabs all the values from the CSV, And from these values, it will predict using the model, and it tells me that it is a fraud. It's 0. So if I take one of these, and it will fetch the data, it will predict from the model, and you'll get the result. It just takes a little time. So my net is a bit slow, so it's not working. Yeah, it says fraud not detected for this data. So basically, that's the Flask app.
You can show them the post application as well, which we applied for the model.
The
post part where we transfer, where we are using the model to predict. Show them that part as well.
Oh yeah, sure. So yeah, I'm just taking the CS. Over here, we just get the transaction ID, and then the transaction from the transaction ID, all the values in the rows are fetched over here, and then the model predicts the and it sends it to the front end. So that's how the Flask app works.
Yeah. So one question I had regarding the data cleaning process. So I see that you all just took the name origin as one of your feature and supplied it to the model. So like you just removed the C and supplied the number to the model. So what was the reason behind that?
Actually, we were told to input it as a field for our model. So either the problem statement was mentioned that we need the transaction ID as an input. So basically, what we did that because we had thought first that what would we do is that we would take that as an input from the user and search it through the data which we have. So because it was not needed as a feature, but what we did that was to like make the searching smooth as well.
But the decision tree model that you have eventually trained,
yes,
in that model, this feature is being used, right?
Yeah, it is a feature there.
Yeah, so that shouldn't be the case because that name origin would be like a unique ID for each person, and having that supplied in the model as a number, that the model would misinterpret that particular feature.
We didn't think about that as well.
Hi. So good work there, guys. And just one question. So in this particular example, according to you, which one is more important, precision or recall?
I guess recall would be more important because the bank does not want them to predict as false negatives, right? Because if a fraud is happening, then if the machine is predicting it as false negative, then fraud has happened and they have lost the track of that. So precision here would basically give them false positives, which is what they don't require. They require false negatives here. So I get more recall should be used over here rather than precision. Therefore, we have not even calculated precision in this case. We have just calculated recall and reference period.
So just want to bring your attention to this fact. Suppose we have good amount of recall, that will somewhere compromise precision, right?
Yeah.
Okay, which means we are going to have more false positives. Correct? What are false positives in this case in your use?
False positives are there are no fraudulent transactions happening, but the model has detected them as fraud. It is okay for the bank, I guess, because if they look into it, they'll definitely found it was not a fraud. So it is okay for them in that case if they are backing it off after that. But if there is a false transaction happening and they're not able to find that, because the model did not detect them. So then it would be a loss for them and the customers as well.
Suppose the bank detects a fraud,
Yeah.
then what do you think it should do?
It should basically it should try to like retrack that transaction, what is happening there, and it should know that it is
Should
happening.
it inform the customer?
It should basically start from start investigation from its side, and then it's obviously customers money and customers account, so basically they need to know as well after that.
Now, what are the kind of frauds which are happening here?
Here there are happening transfer frauds. Basically, the two types of frauds happening in this data are cash out. The cash is flowing off from different transaction destinations, old destinations to new destinations.
So who is the person who is doing the fraud?
Definitely not the bank, someone with some transaction IDs.
It is the customer who is doing the fraud.
Yeah, it is a customer which is doing the fraud.
So customer already knows that it's a fraud.
Yeah.
Right. You don't have to inform the customer.
But for cash outs, basically from which account it has gone, they should know that their from money has been gone from their account to some other destination. So that should be investigated as well.
Okay. So suppose you inform the customer that, okay, there seems to be a fraud and you have a false positive. So actually it's not a fraud, right?
Yeah, the bank should research first on its own, then it should give the report to customer.
I think I want to elaborate on Prachit's point. What Prachit meant to say is there can be two scenarios. One customer who is doing the fraud and other customer who has lost money due to the fraud. So we must inform the customer who has lost money, and from the bank side, they must investigate who has done the fraud. And even if it's a false positive, like even if it's not a fraud, then but our algorithm tells it a fraud, then bank can definitely investigate more if what it actually is, and then do the procedure needful.
So this wouldn't be a real-time solution, right? Real-time in the sense
sorry, could
the
you please
fraud.
elaborate this question?
Yeah, real-time would mean that the fraud is happening and your system is catching that fraud in that particular moment itself. But you are saying the bank should investigate. So do you think the bank will have enough time to investigate and then come up, yeah, this was a fraud or not? Or should this approach be more of a real-time approach?
I guess it should be more of a real-time approach, but for long-term, which is the data which we have here, which is of 63 lakhs, and there are around 8,000 frauds happening in them, which is like a less percent compared to non-fraudulent transactions. So if there are frauds detected here, so I think there should be a way that there should be depending on the score of the model, they should basically think that they want to investigate or not. It depends on the bank or depends on the service which they are using.
And because of the bias of the data set also, it impacts a lot. We could have down instead of downsampling, we could have upsampled and created some fraud data to train it better. But that would have been actually crucial and an incorrect method according to us, because creating of an incorrect data or generating this data is not a right practice.
Even the precision of the accuracy of the data could not be completely correctly made, right? Because there's a lot of difference.
In real time, sorry to interrupt, Prachit, but in real time, as and when we get more and more data, the algorithm can be trained more and much more better to make it more accurate. Or do you agree on this, Prachit?
Yeah, sure.
Thank you so much. Nice work.
Thank you.
Thank you.
Yeah, so if the team has no more questions, they may leave.
Okay, thank you for having us.
Thank you also.
Yeah, so that was the last team of our hackathon. And at this time, I would like to thank all the judges for taking out time and attending this hackathon. We are really honored to have all of you. I would request all of you to wait back a few more minutes. And at this time, I would also request all our viewers I would like to thank all our viewers for being part of this event. And at this time, we'd be also ending the broadcast. Thank you all.